I'm going to be proving the derivative of e ish. And the reason I say ish is because I'm not proving the value of e. There is a solid definition of e that defines it. I'm not going to be proving that in this video. I'm just going to go ahead and hop into it, assuming you're familiar with e. But this is going to be proving the property of the derivative of e to the x is going to equal e to the x. And I'm going to start over here where I'm saying, if you're looking here, all I'm doing right here is I'm writing the derivative of a to the x, right? So all I'm doing is finding derivative of a to the x, like any other derivative. And I'm just plugging those values in over here to the difference quotient. And that gives me a to the x plus a to the x. Let me just restart here. The limit as delta x approaches 0 as of a to the x plus delta x minus a to the x over delta x. And you might know, or you should know hopefully, that a to the x plus delta x can be rewritten as a to the x. That's a terrible a to the x times a to the delta x. Now the reason that's important is because we're going to factor out a to the x here. So I'm going to factor out, because you can see right here, I have an a to the x here, an a to the x here. And so I'm just going to factor that out. And since a to the x has nothing to do with delta x approaching 0, I can take it outside of the limit. So I'm going to write over here, a to the x. Let me make that bigger. A to the x times the limit as delta x approaches 0 of make that shorter, a to the delta x minus a to the, or I'm sorry, minus a minus 1 here. Yeah, because a, when you factor out the a to the x, is going to become 1, obviously. So that's going to be over delta x. And what's interesting about this is you might notice that the limit as delta x approaches 0 of a to the delta x minus 1 over delta x can be rewritten as the derivative f prime of 0, which is the same as d over dx, f prime of 0. Write this neat. Prime of 0. And the reason that's the case is if you have x equal to 0 and you're saying the limit as delta x approaches 0 of this, what you're really saying here is a to the 0, where x is 0, plus delta x minus a to the 0 over delta x. And a to the 0 is going to be 1, as we see right here. And a to the 0 plus delta x is just going to be a to the delta x. So this right here, I'm going to highlight it in this nice color. This right here is just equal to f prime of 0. These two things are equal, excluding the a to the x. These two things are equal here. Alright? So what can we do with that? Well, if we know that these two things are equal, what we can also say is, now I'm going to move this a to the x over here. I don't need it right now, but we will come back to it. So a to the x times, and we're going to have the limit of delta x approaching 0 of delta x here, and we have a to the delta x minus 1. Now, this right here, this is always going to be a constant depending on what a is. And I'll explain that in a moment here. A to the x, a to the delta x minus 1 over delta x, like we just showed, is going to be equal to whenever f prime of 0, whenever it's f prime of 0, right? Because when x is 0, the terms, the exponents cancel out. This becomes 1, and this becomes just a to the delta x. So what that means is this right here will always be the value no matter what a is, this is always going to be equal to f prime of 0. No matter what a is, it will always be equal to f prime of 0. Now, you're going to have different you're going to have different derivatives at 0 for different values of a, but it will always be equal to f prime of 0, no matter no matter what a is. And what we can use that for is over here on this Desmos graph I made and pasted in here. If a is 2, the derivative of this point here, the derivative of when a is 2 will be equal to 0.69. Now, when a is 2.5, the derivative of 0 is going to be equal to 0.92. And when a is 1.1, or I'm sorry, when a is equal to 3, the derivative is going to be equal to 1.1 at f prime of 0. So if we have two values here, 0.92 and we have 1.1, somewhere in here we need to have some value of a to the x, or we need to have some value of a where f prime of 0 is 1. And that's where we branch off with here. Now, the number that makes this true is e. So in other words, the limit, this may go off a little bit, the limit as delta x approaches 0 of e to the delta x minus 1 over delta x is equal to 1. It's equal to 1. So what do we know here? If this right here is equal to 1, if this whole thing in this box is equal to 1, and we have this a to the x outside, and in this case, a to the x is going to be e to the x, what do we have? We have 1 times e to the x. And that's just going to be e to the x. Now, whenever a is, again, no matter what value a is, if it's 2, 3, 4, e, it doesn't matter. The derivative, or this value right here, again, I need to stress this, is always going to be equal to f prime of 0. And so whatever value of x we have in e to the x, f prime of 0 is always going to be 1, right? It doesn't matter because it's x equals 0, f prime of 0. So we're always going to have 1 times e to the x equals e to the x. And we see that over here. This is the derivative over d over dx of e to the x. This is the derivative.